Okay, let's finish our lesson on polar coordinates. This is going to be for if you are trying to write an equation or change an equation from rectangular to polar. So we're going to use the substitutions that we had here, okay, to substitute for x and for y. So if you look here, they have y equals x squared. That's just your standard parabola. Instead of y, they're going to substitute r sine theta, and instead of x, r cosine theta. Okay, so follow along with my equation solving here. I want to solve the equation for r equals. So I have on the left side r sine theta, which is here in purple. I need to square the r cosine theta. So that's going to end up as r squared cosine squared theta. Now in black, I've decided I'm going to divide both sides by r. Okay, so that way that gets rid of the r here. And we get sine theta equals r squared over r is r. And then cosine squared theta is here. Again, trying to isolate the r, so I'm going to divide both sides by cosine squared. So then I have r equals sine over cosine squared. And then what they've done is sort of separate this as sine over cosine, that's here, times 1 over cosine. Okay, so this has been separated, so the denominator cosine is separated into two fractions. Sine over cosine times 1 over cosine. 1 over cosine is secant, and sine over cosine is tangent. So that's how they get to the simplest form here. Let's go ahead and try this with example A. Okay, so let's look at example A. So we know that we are going to a rectangular equation. And so the change over that we have is x squared plus y squared equals r squared. Since r is 2, r squared is 2 squared. So we would have x squared plus y squared equals 4. And it's in rectangular version when you have just x and y. So this is the equation of a circle, obviously, with radius 2. Part B. Okay, so the equation is theta equals pi over 3. So that's going to be all the points where theta is pi over 3. So that's really drawn right here. It should be a line. The unit circle coordinate values for this point on the unit circle would be 1/2 radical 3 over 2. Remember cosine and then sine. So we go ahead and write the given equation from your previous page in your notes. Tangent theta equals y over x. Since theta is pi over 3, we have tangent of pi over 3 equals y over x. And I go ahead and find tangent of pi over 3 from my coordinates on the unit circle. Remember, you may need to brush up on these, or at least print one out, have it available. So tangent is sine over cosine. So sine over cosine. Sine over cosine. So radical 3 over 2 over 1/2. Remember that Mrs. Baker can pause these as you need to so that you can catch up writing this down. The 2's will cancel here, and so this is radical 3 over 1 equals y over x. And we want this to look like a linear equation, so multiply both sides by x right here. Multiply both sides by x, so you get y equals x times radical 3, or radical 3 times x. This way you can see that's a line with a slope of square root of 3. Okay, so we have for part C, r equals secant theta, and secant is 1 over cosine theta. So we have r equals 1 over cosine theta. You can multiply both sides by cosine theta, so that will cancel it on the right side, and then on the left side you'll have cosine theta times r. If you remember back to right here, the substitution x equals r cosine theta, yeah, right here. So that's the substitution that we're going to use. X equals r cosine theta. So then this line is just x equals 1. So this is, if we pull in a graph here real quick, this is a vertical line at x equals 1. Okay. Okay, I believe that completes the notes. You do have a worksheet for Mrs. Baker, and then you also have bookwork, which is on your syllabus table. You can work on both or either one of those in class today. We are on the polar coordinates unit, which is 9.6. I somehow skipped or mixed up section 9.5, so we'll just come back and pick that up, parametric equations, later. So this is section 9.6 if you are looking for the homework assignment that goes with it.